This is Makoto, and welcome to the Joy of D3.js. So, this is what we have built so far. Let's refresh. So I put more data so that it shows a figure every year rather than every 10 years. We also added mouse over event to show the country names. This is getting similar to the Hans Rosling's Gapminder app, which is this one. What Gapminder has, however, is map functionality. If you click this map tab, it transitions from scatterplot to the world map, though it's very, very slow. And this animation reminded me one of the .enter screencast by Ian Johnson, this one. In his talk, he showed his smooth animation between scatterplot and world map, which we can actually play using this one. It's in scatterplot, and if you click this, it transitions to world map. And that's what we are going to recreate with Gapminder today. So here is a list of topics. First, I will talk about two basic D3 API, pass and projection, and one data format called Geo Jason. Then, I will talk about how to transition circles into the map layout and one of the pass feature called Centroid. So let's go to the first commit. When you refresh the browser, you only see 5 years of transition. Then there is a map function button on the left button. Clicking the button render the world map. So let's see the commit. That's actually not much going on. So on line 9, I added a button which calls map function on click. And line 31, there are two functions defined, so projection and the geopass. And line 150 here, boundaries.features are attached to date function as well as the geopass we created earlier, which is assigned to the D attributes of creating a pass. So first question, what is projection? So projection is a mapping from 3D sphere to 2D geographical layout. And if you look into the D3 documentation page here, there are lots of different mapping layout like these provided as an additional plugin. And once you define projection, you can pass projection into the pass function, which is this one. That provides pass generator and various other useful functions. Once these conversion functions are defined, then you need to actually pass dataset. And D3 itself does not actually give you geographic data files. So you need to supply in a format so-called Geo Jason, which is another standard. And if you visit the Geo Jason website, there is a sample data format like this. So Geo Jason consists of so-called features. The important properties you need to know are type that define various data shapes such as like point, line string, and polygon, and the coordinates, which has a lat long pair, and also properties which tend to define various metadata such as name of the city and so on. Let's see all of them together at the playground. If you're looking at the boundaries JSON, it contains a boundary of each country, like Afghanistan, Angola, Albania, and these are the coordinates. Okay. And if you look into the JS file, it defines a projection at line 5. I'll make this bigger. You can adjust size and scale with tributary sidebar. Like this. You can also try with different projections, such as azimuthal, this, or another one is called Alvarez. That. And again, you can play with the sidebar, so it goes like this. So once the projection is set, you set the projection and date set to the path, which is here. If you want to add marker, you can just append circles with projections. Here the example marking UK and Japan. So this is UK's coordinates, and this is Japan's coordinates. And if I do that, Japan I pass as pink, and the UK I pass as blue. And this is exactly what we are going to do next. So let's check out the next commit. And here is the commit log. I added a function called country lat long to filter country name from list of countries. Then I attached the match countries lat long into the same projection. This projection we used to generate one map pass with duration of 1 second. This is cool, but there is actually a better way. If you go back to the documentation page of GeoPass, there are other useful functions, and one of them is called Centroid. As the name suggests, the Centroid computes a central point from the boundaries. This means that we don't have to have the country CSV that holds each country's geolocation. You can again try this out with tributary. So last example. So it's selecting all the boundaries pass. In this code, it selects a pass to get each country's feature and calling a pass centroid, where D is each feature. So if you take this out, you can see those are circles. Though some of the points, I think this is Canada and this is US. Probably it's because it has like Alaska, so center point is getting. Maybe this is Canada and this is America. Yeah. And let's go back to the commit diffs. So I took out the countries.csv because we no longer need it. Then I replaced country lat long with get centroid, which does similar thing. Lastly, I call the get centroid here. Centroid returns the projected XY coordinates, so you don't have to pass to projection functions again. Okay, this is it for today. Thank you for watching.